just wanted to remind you that when you have a double bond, because we're going to be talking a little bit more about alkenes now. So alkenes. So alkenes, if you remember, are the ones with double bonds. Correct. Yeah. Yes, double bonds. They're also referred to as AKA olefins. So these are referred to as unsaturated. So when we talk about unsaturated fats and stuff like that, it just means that they have double bonds in it. And you know, if the when you have a double bond, remember we talked about like you have to hold on to it. You can't rotate around a double bond because the two hands holding it. And so if they're on the same side, it's a cis. If they're on the different sides, it's a trans in there. And they are isomers if it cannot rotate, and it's, and if there's a triple bond inside of there, then you know that it's the alkenes. It's triple bond. And so we've already kind of gone over all of this and stuff like that. Okay, so now we're going to switch kind of how we're working right now. And we're going to switch a little bit on over to aromatic compounds. Aromatic hydrocarbons. Okay. So aromatic hydrocarbons, why are they called that? Well, because a lot of them are fragrant. And we'll talk about some examples of where we get some important ones like wintergreen, vanilla in there. And so they originally were called fragrant. And many fragrant substances were classified as these compounds. And so they got classified as what's called aromatic compounds. So this is where we get the name from. A lot of them are taste. So we use a lot of this base compounds for aromatics for taste compounds, smell compounds. So when chemists used to first start off doing a lot of the chemistry, they would taste a compound. It was part of like their chemistry of it. What did it taste like? What did it smell like? What did it feel like? And then some other chemical properties. But one of the big things they would do is describe the taste, okay, and the smell of the compounds. So the main ones that are out there is our big one is our benzene, which we've already kind of talked about. So our benzene is our one. It's C6H6. It is our poster child for all aromatic compounds out there. Now we do have some other aromatic compounds. If we put two of these rings together, we put two of them. Now remember, there's little hydrogens sticking off all these little 1, 2, 3, 4. Off of all of these little spots here. There's no hydrogen there. Sorry. There's no hydrogen here. No H here or here. Okay. This one is called naphthalene. Naphthalene. So this is naphthalene. This is also known as AKA a polycyclic aromatic. Polycyclic aromatic hydrocarbon. So PAH. So because it's an aromatic hydrocarbon, there is multiple of them stuck together. Now, a PAH is not just naphthalene. Naphthalene is just an example of a PAH. There are also any of them that you have multiple aromatic carbons come together. Now, PAHs, we will get into them more later on too. They're one of the big contaminants. Again, PAHs are polyaromatic hydrocarbons. They were used for a lot of different things. We'll talk about them when we talk about burning, like coal. You get these, they're 16 priority pollutants, and they're the polyaromatic hydrocarbons known as carcinogens. We'll talk more about them. I'm hoping one of you guys does a paper on PAHs and their transport. They don't move very fast. Again, benzene moves pretty quickly, but once you start sitting down these other organic compounds, we'll talk more about it later, but they tend to stick. They're harder to break down. PAHs, I'll show you a site that is located in Calumet. I think I've mentioned the Calumet site before. It's got a pH of 13. But this site, there's right next to it, they were doing Coke manufacturing. manufacturing. So not Coca-Cola, Coke, but Coke as in pure carbon for steel. So when you make carbon for steel, when you have steel manufacturing, you take coal and you get rid of all the impurities out of it, and so that you end up with Coke, which is just pure carbon. Well, all those impurities that come off of the coal, a lot of them, are things like PAHs that come off. We use a lot of times PAHs for like asphalt. It's that liquidy part of asphalt, like creosotes. We'll get into creosotes and stuff. So a lot of these things are all kind of lumped together under this polyaromatic hydrocarbon. So it's a really PAHs, very important abbreviation for you to remember. So if you're going to go into this field, they're going to talk a lot about PAHs and pH contamination. So please, somebody, do a paper on it, but we will be talking more about PAHs. Okay, so that's naphthalene inside of there. These are PAHs if they've got multiple, and we'll go more into them later on, into there. Then we have our benzene ring again. If we stick on an OH group on here, this becomes phenol. Okay. Then if we stick another functional group, say we want to put a methyl group on there. If we stick it here, we call this the ortho. This right here is the meta position. And this right here is the para position. Ortho, meta, para are Greek words. I'm reading close, far, and really far away, basically. So ortho, meta, and para inside of there. And so if we had a compound like this, and there's two different ways we can name this compound. Let's stick this here. So what do you think this would be called? I'm going to give you a second. Okay, so what did you guys come up with for a name for this? Well, we could go, this is the 1 carbon, this is the 2, 3, 4, 5, 6 carbons. So we name the carbons just like we have before. We number them. Also, this is in the ortho meta, so this is also the meta position. Okay, so this compound right here could either be 3-chlorophenol or metachlorophenol. Okay, so it's either one. So phenol, you have to memorize that has an OH group onto it. Again, phenol and benzene, because these are old compounds from aromatics and people were investigating them, they came up with names for them. Even though this has an OH group, this could probably be benzyl alcohol or something like that. This is phenol, so just keep that in mind. So this is either 3-chlorophenol or metachlorophenol. Both of them are correct. Okay. So another one to memorize is this one right here, which you'll have to memorize, is if we put a CH3, we put a methyl group on there. This is toluene. Okay. So toluene, again, is that, you remember we talked about BTEX, BTEX. So this is our benzene. This is our T for toluene. Okay, so the E here stands for ethyl benzene. So I bet you can figure out ethyl benzene. What do you think you do? You stuck an ethyl group onto it. So you put a CH2CH3 off of it. Out becomes ethyl benzene. We'll get into xylenes in just a second. Xylenes, I'll do xylenes now, and then I'll come back to one thing I like to talk about here. Xylenes, so this is our E, and then our T. Now I say xylenes. Xylenes, because if I draw this, there are 3 different xylenes. So xylene is basically with 2 methyl groups stuck to it. So remember we talked about it being in the, so you have a methyl group on the top position, so it becomes toluene. But if we add a second methyl group in the ortho, meta, or para position, they become xylenes, and so it's in one of these positions. So you would have orthoxylene, metaxylene, or metaxylene and paraxylene. But what we usually just refer to those as O-xylene, M-xylene, and P-xylene. So we don't usually write out the word orthoxylene. We just usually put O-xylene, M-xylene, and P-xylene. But what usually happens in pollution and how these migrate in the environment are exactly the same. We'll talk about detection of these in the environment and how we find them. And these all come out, they're actually kind of hard to separate on a gas chromatograph. We'll talk about a GAC for detection of xylenes later on. Because of this just slight difference in this, we lump them all together. So, and then when we talked about, remember we talked about gasoline and how they're manufactured and everything? These come out in equal proportions in almost all gasoline. So we usually don't separate them. Now you can, and we can go into certain research papers and stuff where they actually do separate these out from each other, but we just kind of lump all of these compounds together into our xylenes. So now you understand BTEX. We have benzene, toluene, ethylbenzene, and xylenes. And so when you write out BTEX, if I give you a homework assignment, hint, hint, keep in mind that I'm going to put this, you have to draw all three. If you just draw one, you only have drawn one of the three xylenes, and you have to draw all three of them and indicate which one is O, M, and P. Okay. Going back to my toluene here, I'm going to draw a compound, and I want you to kind of think about what would be the name of it. So we've got our base little group here. So there's our methyl. We've got a CH3, NO2, NO2, NO2. Okay. So this particular compound, what do you guys think? Okay, so we'll give you a little bit of time here. Okay, so I'm going to give you guys a little bit more of a hint here. When we have a little functional group of a nitrogen coming off of that, we refer to that as nitro. Nitro. So now that you know that those are nitro, how many nitro groups do we have? 3. So it's trinitro, right? And so this is our toluene. This is our 1 carbon, 2, 3, 4, 5. So this is 2, 4, 5, trinitro. And then this up in here makes it toluene. What's another name for trinitrotoluene? TNT. Dynamite. TNT. Oh, sorry. I'm singing songs. I like classic rock. But, well, I like all music, but yeah, classic rock. So, TNT. Your dynamite. And so this is TNT. So, trinitrotoluene. So, we now, you know now, like when you have this nitro group, stick off into it, you know this is a chloro group here. You know your aromatic compounds, you know your benzene, you know your xylenes. So much to know about organics, okay? The next thing I was going to talk about with organic compounds